Okay, so maybe we can get started. To start with, a couple of months back, Aubrey and I were discussing about a new seminar series. And we came up with, because we are expanding our research efforts on AI foundation and application. So Aubrey and I decided to start a new series focusing on that between the Encore Institute at UCSD and TTIC. So we are really happy that Emily Wenger is the first speaker of that series. And we are also hosting this series through our Foundation of Data Science channel, which is going on since 2018. And we started this effort between me, GV, who is here from Syracuse University, and Clemo Cannon from University of Sydney. So we are broadcasting Emily's talk through that channel as well. So today we have Emily Wenger from Duke University. She's a new assistant professor at Duke University. She got her PhD from U Chicago, and then she was a research scientist at Meta. Emily has done fabulous work in AI security, and her work has got tremendous attention from various media. And she recently got the 2024 Forbes 30 under 30 for her work on Glaze, which protects the artist's right from AI violations. And we are really happy that, Emily, you are here today to talk about your exciting work in data governance and AI security. So welcome, Emily.
Thank you so much for having me. To everyone at UCSD, I'm sorry I'm not there in person, but you don't want me there because I'm not feeling super great. But yes, I am happy to be here, excited to talk about data agency and mechanisms for retaining some control over our data when AI and machine learning have become essentially ubiquitous. So I'm going to talk. If you have burning questions, feel free to I don't know what the best mechanism is. Maybe drop them in the chat or raise your hand. Whatever you've done before, it works great. And then you can also save questions for the end. So I want to be as conversational as I can, but don't want to get too derailed in questions. So here we go. As you all are probably well aware, machine learning / AI, I will use those terms interchangeably, and I'm sorry, that's just what I do, have become ubiquitous. So AI models or machine learning models are in web browsers, phones, finance applications, healthcare applications, our cars, and even recently have become integrated into various operating systems through things like the new Google Pixel 9. Well, that's very interesting. Regulations and controls of these systems are incredibly nascent / non-existent. As of very recently, there are kind of three main threads of legislation dealing with AI models and how they're supposed to behave. The big, most recent one is the European Union's AI Act, which is designed to sort of regulate and control risks in AI use. There's also the EU's GDPR, which is more focused on data privacy. And then in the United States and elsewhere, there are a growing number of controls around biometric use cases for AI. But as far as codified legislation goes, that's pretty limited. And in particular, the existing laws and legislation that do exist focus mainly on biometrics, as I mentioned, and then in ascertaining risks of model use cases. They're not so much focused on model training data and its provenance. Yet, as you may well be aware of, the training data sets for these really big AI models are often composed of data taken without meaningful consent. Often these data are scraped from the internet, and people who provided that data are often unaware that the picture they posted on Flickr in 2013 has become a key component of a training data set used for various foundation models. So the reality is that there's a lot of commercial models out there trained on personal data, data that individuals never knew or expected would be used in this way. As you can imagine, there are a fair number of existential problems with the use of personal data in machine learning or AI systems. The biggest one is that user privacy is violated. Big AI models, particularly generative models, have been shown to easily regurgitate training data, which can include private information. And until biometric regulations have become stronger, sometimes the use of one's data in a system meant that you were unwittingly enrolled in something like a face recognition engine. This was most kind of publicly the case with a tool called Clearview.ai, which burst on the scene around 2020. Clearview has since been sued out of existence, but sort of imitators have popped up ever since. But additionally, besides privacy violations, the use of personal data in ML system violates user autonomy. You can't choose how or when your data is used if you just get caught up in a large-scale internet scrape. And now that models are being commercialized, other people are profiting from the use of your data, which has kind of always been the case, but it's taking on different meanings as generative AI has become more and more profitable and mainstream. Of course, people know about these problems, and there are solutions that have generally focused on preserving data privacy. So most prior work surrounding data use in machine learning has focused on shielding data content. So operating under the basic assumption that data use is inevitable, and then working to make sure that unauthorized people cannot see that data. So we have methods like encrypted model training and differential privacy, federated learning, among other techniques. And while that work is important, I believe there is a lacking complement of work that focuses on the autonomy question, not simply providing users with protection once their data is used, but questioning the premise that their data should be used at all. So essentially, existing solutions assume that the use of individuals' data in machine learning systems is inevitable. And I would question, is it? Or have we just created a world where it has become inevitable? And if that's the case, what mechanisms or controls can we create to counteract that behavior? Specifically, during my PhD and in my thesis, I proposed this idea of data agency, which pushes back against this prevailing narrative of inevitable data use, and instead argues that individuals should be able to know and control how or if their data is used in ML systems. I believe data agency can and should take many forms. It needs to be supported by legislative action. There needs to be corporate policy change to make this possible. But there is also space for technical tools that can support this kind of thing. And today I'm going to focus on 3 different technical tools that I've been involved in creating that are meant to promote data agency. So in the rest of this talk, we're going to briefly look at why data agency is possible at all. Then we'll take a look at the 3 proposed data agency solutions I've been a part of, and then we'll conclude with some future-looking discussion. So the key intuition behind all this is that machine learning models need to learn from data. That's their whole thing. And so in a sense, users have power in affecting how models learn and behave because they themselves create the data. I just want to throw in a little editorial note here that I think this intuition and this chain of thought, chain of command, whatever, where users' data has power, has become even more pressing in light of recent work showing that generative AI models trained on generative data basically collapse. Because this means that human users who are creating new data suddenly have kind of a gold mine of data that's more valuable perhaps than it was before, and certainly higher quality than data that is previously generated. So I think that's going to be an interesting corrective and addendum to this in the future, but digression aside, because individuals' data affects model behaviors, individuals can leverage the fact that they are crucial in this machine learning pipeline to create solutions that disrupt or detect unwanted ML data use. And that's how the data agency solutions that I've proposed work. Disruption assumes that we can, or operates on the premise of corrupting an individual's data in specific ways that make it relatively unusable in AI systems. And detection uses, again, individuals' data and uses certain properties of it that we can create to detect if it was used to train an AI model. So that's the 10,000 or maybe 30,000 foot view of data agency. And now we'll turn our attention to discussing potential data agency solutions. So like I said, we're focused on techniques to disrupt and detect, although certainly these are not the totality of potential avenues for data agency. They're just the ones that I focused on. So please be creative in thinking about this in the future. But one main avenue of disruption, as I alluded to, is the ability to make one's individual data unusable, rendering it just basically useless for the AI tasks. The two projects that I've worked on towards that end are Fox and Glaze, which we'll talk about today. And then detection mechanisms by tracing individual data use. That project is called Data Isotopes, and we'll discuss it in a bit. So kind of the prototype for all of this work was Fox. Fox was a solution designed to counteract tools like Clearview.ai, which trained facial recognition engines on internet selfies, basically. And the key idea of Fox was to change the feature representation of images posted online to prevent them from being successfully used to train facial recognition engines like this. We're going to touch on Fox very briefly, so this is super high level, and I apologize if it causes some confusion, but I want to focus elsewhere today. So Fox works as follows. The image I just popped up, the XY plane here, is a very simplistic rendering of how a facial recognition image classifier draws decision boundaries between people it wants to recognize. The small icons, like in my case, the triangles here, represent individual images that the model has seen during training. And then the broader ovals that I've drawn around them represent the broad feature space that the model has learned to associate with that person. So this model, which has been correctly trained, will see a selfie of me from somewhere. Maybe someone feeds it into this facial recognition engine. And because it's learned to associate that bottom right region with me, it will correctly classify me as me. Fox uses an optimization procedure to change how the machine learning model ultimately views images of me in feature space. So in this case, we've optimized or cloaked my images to have a feature representation that looks a lot more like Beyonce's than my true representation. And a model trained on this set of data will learn to draw a complex decision boundary between me and Beyonce, while basically leaving my true feature space uninhabited. That means that when the model sees this image of me in the wild, which appears in my true feature space region down in the right, it doesn't know who I am, and so classifies me as someone else, like Ben. So Fox was sort of the OG of all of this work, and it got some attention, and we had a fairly robust mailing list, which we still get messages on. And there were lots of interesting suggestions on the mailing list, interesting conversations we had with people, creepy conversations we had with people. But one helpful suggestion came through to us in June 2022, when someone named Kim emailed us and said, hey, I'm wondering if Fox could be used to prevent generative AI models to prevent basically IP theft from artists. And we thought, that's kind of an interesting suggestion, and filed it away. But as we thought more and more about it and read more and more about this problem, we realized that, sure, the use of face images in a case like Fox, or in a case like Clearview, can cause privacy issues. One could, in the worst case, argue that this could totally be mitigated by erasing one's online footprint and choosing not to engage in any social media, and so avoiding being scraped. With some edge cases aside, that would probably deal with this. And also there's legislation saying things like Clearview are not okay anymore. However, the issue of using art for AI training is a bit stickier, primarily because artists in the modern age cannot erase their online footprint. Artists rely on online portfolios and other means of sharing their art in order to advertise and gain revenue. And so when that art is used to train generative AI models that can then imitate artists' styles, artists are caught in a bind from which it's very difficult to escape. And so just to illustrate this a little bit more concretely, I'll take you through the story of Kelly McKernan. Kelly is an artist that we got to know and work with through the creation of the tool I'm now talking about, which is Glaze. So Kelly is an artist. She's very talented, and from an early age, she loved art and drew a lot of pictures and used a lot of different mediums. And as she grew, she began to refine her style and understand exactly what she liked to do and what she was good at. And eventually, she refined it so much that she became a professional artist. And she has this very distinctive style that is popular and has gotten her a lot of commissions and work. And Kelly's business model is similar to that of a lot of other artists. She maintains online portfolios on a personal website, on a website called ArtStation, and Instagram, among other places. And the point of these portfolios is that people see her art, it gets visibility, and then she gets commissions to design concert posters or programs for Evanescence, and also sells online prints. However, Kelly learned a year or two ago that over 50 of her paintings were used to train image generation AI models. She wasn't aware, she wasn't compensated, she didn't get any credit. And while that in itself is a bummer, the bigger problem is that these image generation models were trained in such a way that they began to actually mimic Kelly's style. So on the right, the trifecta of images are actual images by Kelly, and on the left are images drawn by an AI that was trained specifically to mimic Kelly and was given the prompt listed at the top of the slide. As you can see, this is pretty good. The AI has done a pretty good job of capturing Kelly's style to the point that maybe someone would be willing to just use this art instead of paying Kelly to draw this for them, or even paying Kelly just for a print. And Kelly's story is a microcosm of a much broader problem. Style mimicry, the idea of training AI models to just mimic an artist that you like so you don't have to pay for their work, has become an industry. So you can see these three examples are pieces of art for sale generated by AI designed to mimic a very specific artist. And so what happens is AI enthusiasts scrape images from artist websites. They train a specific mimicry model designed to disrupt a specific, or to mimic a specific artist, and then they post them online so anyone can download it, and then replicate their artist. And ironically, some of these AI mimics ask for donations to support their work, which is kind of funny. Essentially, what is happening is this. And the truth is that AI art harms artists' livelihoods. And this has been well documented in the in the art community, and was confirmed in our survey of professional artists last year. So there's just an incredible sense of defeat in the artistic community about what to do about generative AI and image generation models. You can just kind of go through headlines like we did in Twitter/X, and you can see dozens, hundreds of artists just sad and feeling like the situation is hopeless and that art really doesn't have a future as generative AI begins to take over. In face of all of this, we wanted to do something. We knew we couldn't do everything. We knew we couldn't solve this problem in totality because it's much bigger than just stopping unwanted AI art training. But we wanted to provide some sort of solution. And that solution eventually became the tool known as Glaze, which was a tool designed to protect artists from this unwanted style mimicry by AI models. Glaze is available online. It's designed to just train, or it adds certain perturbations to your art, such that if a model is trained specifically to mimic that style of artwork, it will be unable to do so. There's a paper, you can read it, and you can obviously read about it on our website. But I want to give you more of the behind the scenes on Glaze and some updates on Glaze in light of some recent criticism. So the timeline of Glaze was that in June 2022, we had some artists reach out to us. We then reached out to artists who were actively wrestling with this, including the Concept Art Association. Concept artists are the people who do art behind movies like Marvel movies or Disney movies, and they're particularly worried about generative AI because I don't know if you heard, but Disney just started training an AI model on its whole library of content, which means that people whose job it was to imagine and dream what a movie could be may have their jobs threatened by AI that is being trained to do that for them. So lots of artists are worried. Concept artists are particularly worried. Then over 2023, we worked with artists. We did a user study. We developed the tool. Glaze was released early last year. It got a lot of media coverage. And as of earlier this year, there were almost 2 million downloads of the app that we had released. So at a high level, Glaze works as follows. Without protection, you can take an artistic image like this or a subset of an artist's library, and you can fine-tune a stable diffusion model to mimic the style of that artist. And as I showed you with Kelly's work earlier, and as you see here, it's pretty good. It can capture a lot of details that would make it appear that you've just, mimicked the artist. The goal of Glaze is to disrupt that process in as subtle a way as possible. So Glaze, similar to Fox, runs an optimization procedure designed to change the underlying style of the art. So it will optimize it in a feature space in a style conversion model that, while maintaining visual similarity to the original piece, perturbs the style of the art as far away as possible from the original style. In this case, I believe the target style was Vincent van Gogh. And so you can see that this model fine-tuned on the glazed art is basically producing weird Vincent van Gogh hybrids when asked to imitate this particular artist's style. Glazed artwork, however, looks fairly unperturbed. These are some examples of art from partner artists that we worked with as we were prototyping the tool. We did a lot of work, or rather, I should say, Sean, who is a PhD student in Ben Zhao's lab, did a lot of work to make particularly black and white images appear relatively unperturbed by glaze. Just to give you a few more examples of how glaze works, here are 3 examples of art. The top row is from Nathan Fox. He's a concept artist who works with Disney, and then Monet and Van Gogh. When you try and mimic this art without protection, it again looks pretty good. But when you mimic it with protection, I don't know what the target styles were, but I assume they were something abstract. It doesn't look quite as good. And in our original Glaze paper and in updates since, we did a lot of adaptive countermeasures. So we did the base look at mimicry as a service, and then we deployed as many countermeasures as we could reasonably think of to test and stress test glaze behavior. However, there was a significant debate around the decision to deploy glaze at all. Glaze has limitations, and we experienced this with Fox, which has had also some pushback. We knew it was not future-proof, and we were worried that artists would misunderstand what we were presenting as a silver bullet and not a temporary solution as other tools caught up and got better. But we were working with so many artists who were so nervous and wanted anything that would help. So we decided to deploy it, and it really touched a nerve and became very popular. We did the best we could to make it very usable, but we were very clear on our website and in all our communications, we thought that of the limitations about this work, and tried to be as transparent about what it could or could not do. Artists were thrilled. It was a really nice thing to get people saying nice things about research that we had put out there. They were very grateful that we were at least trying to help, because the artistic community has, making broad sweeps, felt a little abandoned in the race towards generative AI. Artists helped us design the app and took what we did and used it in a couple of different educational campaigns. And we've been requested to do follow-up work from a variety of different types of artists, including a choreographer, which was interesting. So while Glaze was very public, it has inevitably received some pushback. And there have been a few recent works demonstrating different mechanisms to evade both Fox, although that was a year or two ago, and then more recently, Glaze. This was in the world of security where everything has a half-life, unless you're, RSA, although that has a half-life too. This was sort of expected. What was a little harder to reckon with was the argument in this work that Glaze and Fox are actually irresponsible research because they are providing a false illusion of security at all. The argument is that if you are an artist or someone posting a picture online, you have one opportunity to protect yourself by using one of these tools. Versus if you are an adversary looking to strip that protection, you have infinite chances. And so it's a fundamentally imbalanced game. And I think there's certainly validity to that argument. It is a tough game, and the power is not in the favor of people who are trying to protect their data online. It's been a big controversy. It's been somewhat stressful, and I just wanted to offer a few of my own thoughts. In full disclosure, I have not been as involved in the development of Glaze since the end of last year. That is Ben's lab. They're doing great work, but this is my somewhat outsider's perspective from someone who used to be much more involved than they are now. I think that this is really lose-lose. If Glaze didn't exist, I would argue there's some technical harm and a lot more psychological harm, as the artistic community just feels more and more abandoned and hopeless. But as these pushbacks have shown, anything we do is impermanent at best. And so it seems really complicated. The world around AI is very fast moving, and it's, I don't know if any of you have seen the show The Good Place, which is kind of a satire on morality and ethics. But essentially what they find in the show is that anything you do is morally neutral at best because everything that you do is so complicated. And that's kind of what it feels like in this space too. Another thought related to some of the criticism of Fox and Glaze, some critics have said that legislation is kind of the only way to deal with this problem. I really don't believe that, mostly because I think legislators, while well-meaning, are at best very slow and at worst don't necessarily understand the technical nuance. And so relying on legislation alone to solve this problem puts artists in a real bind and may actually never realize the kind of solution that we're looking for. So I think technical tools have a role to play here. And I think at the end of the day, like, as a research community, our goal should be to encourage creative solutions to this kind of unauthorized data use while not being naive about the limitations of these tools. It's up to us as a community to figure out how to deal with the unintended and unwanted side effects of AI models. And I think we're at a place as a community where we're throwing a lot of stuff at the wall and hoping something sticks. And well, of course, it would be great if we had more provable options or more fundamental truths we could grab onto. The truth is that AI models are fluid and hard to understand and almost impossible to prove a lot with. So we're working with what we have. So that's my take. I'm sure there will be questions. So maybe we can save questions about this specific topic to the end because I could go on for a long time. But that is that. And I want to just spend the last few minutes, although I'll do my best to stay within time, talking about a different tool for data agency, which is detection via data isotopes. So Glaze and Fox are trying to disrupt the flow of data in a system and see if we can add friction and make AI model trainers less likely to use data that we don't want them to use. Data isotopes are more accepting of the fact that data may get used, but want to retain some control and knowledge over that data to know if that data was used at all in model training. So maybe you want to check if a model is complying with GDPR's right to be forgotten, although this in itself is complicated. And there's a lot of other use case where one can imagine just wanting to know if your data was used or not. So the solution here is that we create special data isotopes, which are modified data points whose influence on the model during training can be easily detected post facto via model queries. So here's kind of the motivating scenario for data isotopes. Excuse me, I'm just going to take a drink of water. So Alice wants to share images online via one of many social media platforms. Time passes, and Alice then sees later that maybe one of the platforms with which she shared data is now offering a new classifier that they trained. And Alice is just curious, like, did they use my images to train this model? The key idea of isotopes is that it would allow Alice to answer this question. So it would modify some of the information Alice chooses to share in such a way that Alice can, down the line, when they see that model, gain more insight into their data use. But in developing isotopes, the key question is, what can Alice control? And as I sort of alluded to in the Fox and Glaze discussion, the answer is not a lot. We separate out here the model training pipeline into 4 key stages, which are a bit overly simplistic, but work. The last 2 stages are the collection of data and the training of the model performed by the collector and the trainer. And we assume the trainer can do everything. So they are able to control how the model is trained. They are able to label the data that they have collected and maybe change the labels from those received from the data collector. But one thing we kind of assume that is, I think, a very reasonable assumption is that neither the collector nor the trainer does much, if anything, to the content of the data that they have collected. They need the data. Their model relies on it. And so modifying it is A, hard at scale, and B, fruitless if they want to actually learn from the real data that they're working with. We assume the platform just acts as sort of a non-participatory host, so they don't really do much. But Alice themselves can really modify the data content, and that's it. So we assume that she could make changes here that trickle down through the system because the collector and the trainer rely on her data, and that those changes could enable data tracing. So the goal then is to build a mechanism to detect unwanted data use by only manipulating the content of user data. I just want to quickly separate this out from prior work on data tracing. So we can't assume that Alice knows other people's data that is getting scraped. So there are some works on watermarking full data sets, but it assumes that you know the whole thing, which is just not true in Alice's case. We also saw in the previous slide that Alice can't control how her data gets labeled. There have been some mechanisms proposing data provenance via backdoors, which are basically targeted misclassifications trained into the model, but most of those require control over data labels. Furthermore, Alice doesn't really know what the downstream model is going to look like. So prior work assuming knowledge of the feature space is not helpful here. And finally, we assume Alice has query-only access to the model. Prior work assumes full white box model access. And while that may be relevant in some cases, like Llama is open source, many AI models these days are hosted and accessible only via API. So existing solutions do not address the specific constraints of trying to trace data use in a black box model scenario. So we developed our own. Data isotopes work as follows. First, Alice marks images. We're assuming here an image classification context. She marks her images with a spurious feature, which is a feature not characteristic of her class, creating a data isotope. So if it were a facial recognition scenario, Alice might mark her image lightly with this little turtle, which slightly disturbs the visual quality of the image, but that can be traded off with protection strength. Then if these images are used during model training, the model will learn the spurious feature as associated with Alice's class in the model. And then Alice can use the spurious feature in a testing procedure to detect whether her data was used. And the key intuition here is that the use of the isotope feature changes the model's predictions in a non-trivial way. And specifically, training on isotopes will increase the probability of Alice's label for images with Alice's mark. So assume we have a model trained on isotope images for class 7, and that's the class associated with Alice. So it could be a face recognition model, or maybe Alice posts a lot of class images, or excuse me, cat images, and class 7 of this animal classifier is cats. So if the model were then queried with this image of a different person whose true label is 0, you can see the probability distribution here coming out of the model. So probability is highest for class 0, which is the true class. And the probability of Alice's class 7, which is in blue, is rather low. But if you query the same image again with a marked image containing Alice's isotope, we see the probability of Alice's class jump significantly, tenfold, from 0.01 to 0.1. And essentially, if you repeat this comparative testing procedure with a larger set of images and then run some statistical tests on this, you can guarantee with some high significance level that, or with some high probability level, that you have found a model trained on images with this particular isotope mark. So the experimental settings that we evaluate are as follows. We really focused on object and face recognition. We also looked at ImageNet, which is not listed here, so we were testing with models up to 1,000 classes. The key things we wanted to vary here were alpha, which is how visible the isotope mark is, and rho, which is the proportion of the class label marked. So ideally, you would be able to have a consistent detection of image use when alpha is low and rho is low. But in reality, it seems that these two trade off a fair bit. And we use this VT metric, which is the true positive rate of an isotope verification procedure that is described in the paper. And essentially, the question is asking, what proportion of the time does a verifier correctly detect that isotopes were used? I'm really glossing over these details, but they're in the paper, and I can discuss more in questions if you care. This heat map here shows the trade-off of isotope performance as you increase the amount of data marked along the x-axis here, rho, and as you increase mark visibility, alpha. So we would expect that if a lot of data is marked very strongly, we would have a high success rate of 100% or proportion of 1. And then as we decrease these two things down to 0.1 and 0.01, we would expect that it would fail. And we want to get the purple, which is better performance, as close as possible to the 0.0 point. What we see is that in this case, we can have a fairly high detection rate when the mark visibility is above 0.3 and when at least 10% of Alice's images are marked. So that's quite good. If you look at images in the paper showing the visibility of the mark at this setting, it's not that visible, which for a social media setting is the goal. We also test a different characteristic of mark distinguishability if multiple classes are marked in the same model, and we find that that also remains high. We did a lot of different experiments exploring the limits of isotopes, stress testing them. So we found that they scale pretty readily to larger models where up to 100 classes are marked. We tested them in a black box training scenario where we don't control anything about the model training procedure. We just feed, in this case, Google Cloud Vertex data with isotopes, and we found that isotopes are fairly successful there. And then we also tested a transfer learning scenario where we had a foundation model trained to do a task, and when we do transfer learning, we insert isotopes into the data set and find that detectability remains high. We also did a lot of countermeasure testing, and what we found was that the countermeasures we tested either fail or impose a significant cost on the model trainer, which may or may not be practical for them to incur. Those details are in the paper. So the idea of data isotopes is that it enables practical data use auditing, and we found that it's robust against reasonable countermeasures. I think there's a lot of avenues for future work here, including exploring isotopes in other domains and providing more theoretical explanations for their success. And just tying back to the main theme, isotopes are a mechanism for data agency because detection is a key component of data agency. Disruption, of course, matters too, but even just knowing whether or not one's data is used is an act of agency that is important. So just a few concluding thoughts before I open up for questions. I just want to reiterate, we really live in the Wild West of machine learning and AI, and it's a very interesting time to be a researcher here. It means there's a lot of opportunity. I also think it's a little scary because there's a lot of responsibility to be developing solutions that will put guardrails on this technology for future generations. So just want to encourage all of you working in this space that it's fun, it's wild, and good luck. But the discussion in future work points that I wanted to make were that as you think about perhaps developing data agency solutions of your own, I would note that to make this concept actually realized in our society, we need both tools enabling knowledge around data use in the first place, and I think these are severely lacking, and we need mechanisms to control data use. And in both cases, there needs to be interplay between legal and policy measures and technical tools, because I don't think either can subsist without the other. And then if I were to dream and suggest future avenues of work that I think are interesting, I really think we need continued and increased government academic collaboration to build tools that can actually enforce regulatory standards. I think an interesting failure case for this is machine unlearning and the GDPR right to be forgotten law, which GDPR right to be forgotten basically mandates that you have to, if a user requests it, remove their data from your system. And basically that birthed this field of research called machine unlearning, attempting to remove the influence of a user data points from an ML model. But it turns out that's very complex and almost impossible to do in practice. And it seems like we would have benefited from more discussion between policymakers and academics or researchers in the first place to develop a more tenable solution. I also think, as I mentioned early in this talk, that revisiting data agency through the lens of model collapse would be very interesting. This almost feels like more of an economic analysis than anything else, quantifying how much more power users get when all of a sudden they hold data that's more valuable than it was before. But that's an interesting question. And then finally, I think we need much more visibility into data scraping. There's some work, including the Data Transparency Project, I believe it's called, that is providing some of this really valuable work, but I think knowledge is power. And if we had more understanding of where scrapers are at work and what they're doing, we might be able to find our way to some better solutions for data agency. And with that, I think I'm out of time. And so I'll open it up for questions. Thank you.
Thanks a lot, Emily. So let's go for questions. So for questions, you can unmute yourself and ask questions.
Hey, Emily, really nice talk. One question, like regarding the Glaze data set, like the results that you showed, like one with cloaking and without cloaking.
Yeah.
So did you generate those results with a prompt, or were they like promptless images that were generated for a particular artist?
Let me just make sure do you mind saying who you are as well? Because I can't see names.
GV.
Oh, wonderful. Okay, nice to meet you. Are you talking about this slide?
Yes.
Yes. So yes, both are developed with a prompt. So the left obviously is actual art. The middle is prompted to develop, or the model, a fine-tuned stable diffusion model prompted to produce art in the style of Nathan Fox, Monet, whatever. And then the far right column is that same prompt, but when the model has been fine-tuned on glazed images. Does that
Okay, and
clarify the
also,
question?
like the cloak, yeah, the cloak that was added, the cloak or the mask, or
Yep.
so you pick a target artist at random, like, or is it like arbitrary, like, or do you
Yeah.
try to pick a target who's farthest away from this guy?
There, I believe, are like multi-step criteria. You want to get as far away as possible, but you also don't want to always go to a particular outlier. So it's randomized, but there's a minimum distance you have to cross to be chosen as a target style.
Okay. Okay. I guess that answers two of my things. Like just a quick, I don't know, like this is more of a brain fart. So every time, like say, like a artist like uploads an image, there is, let's say, another twin image that is uploaded, because most of these scrapers are tools which are just like pulling out all possible images from a particular website, let's say.
Yep.
Right now, so they don't really cherry pick particular images which are uploaded by a particular artist. So if they are just doing a bulk download, let's say, or a bulk scraping. So for every correct image, let's say there is another twin image which aims to undo the effect of training a model on that, on the true image. Like, could something of that sort be possible? Like, would you be able to generate a twin image that undoes the effect of training on the true image? So something like machine learning, but it's like learning with additional steps of training on more data.
Yeah. So in this case, you're assuming you kind of take advantage of the time evolution of these models and the fact that they get fine-tuned on new data that's scraped over time.
Yeah.
Yeah. I think that's interesting. I think it would depend kind of on the, like at a basic level, that's interesting. And I think that's another area that's underexplored, is like what happens as models evolve over time, and can we use that to our advantage in preventing unwanted data use? My more political answer is it would kind of depend on the mimic, because like the scenario in the middle here assumes that you go into an artist's site and you have images kind of tagged with their name, and you use that to develop this style mimicry model. And you're talking about a more generic scenario where you're just kind of not necessarily targeting a specific artist. Is that correct?
No, you could do the same thing, but I'm saying, like, for every true image, I also put up a fake image.
Yeah, I think that's really interesting. Definitely a good avenue for future work.
Also, like, have you tried like other modalities of data, like instead of image, let's say like voice data or videos or something?
I know that Ben's group published a paper earlier this year on video protection. That is the only other modality I'm aware of. There is some work on voice cloaking. That one feels even harder though, with the advent of zero-shot voice synthesis models. Like as soon as a 5-second snippet of your voice is out there, they can basically mimic you. But that would be important for future work as well.
Right, sounds good.
Thank you.
Thank you.
Other questions? Well, your talk has been very interesting, and it seems like it's like flooding with a lot of theory questions that we can probably work together. So very exciting.
There's lots of interesting theory questions, I think, arising from this for sure.
Yeah. Okay, David, you can go ahead. Yeah. Hi, David.
Hello. Yeah, so thanks for that wonderful talk, Emily. David Danks here at UCSD. I'm actually going to pass it off. I'm running a 2-week undergrad program, and we all just did a group watch party of your talk, and one of the students had a question, so I'll pass it off to them now.
Thanks, David.
Hi there. Super happy to actually hear from someone who worked on Glaze. I'm an artist myself, so I've heard a lot about this. One of the things that I was kind of interested in asking, because going on Reddit and sort of like being part of a lot of like artist groups, not a lot of them have a lot of exactly understand how Glaze was developed. And one of the things that they mentioned is that this argument that if you're using Glaze or Nightshade, which I actually wanted to ask about, but
Yeah.
that's another thing. But if you're using Glaze or Nightshade, you are essentially like doing the exact same thing that AI artists or AI image generations or generators do. And that is Glaze using data, like for example, the Lion 5B data set, or like just using art image data sets in general? Or is that just like a misunderstanding of what is happening with Glaze?
Can you kind of clarify what the concern is? Is it that in the development of Glaze,
Yeah.
large scale AI data sets were used?
Yes,
Or-
that's exactly what it is.
I see. It's a great question. So Glaze, for the targeting part where you select a target style, Glaze is using open source data sets, including you're going to have to look in the paper. I'm sorry, that's not a great answer, but all the data that we use is in the paper. There's a artist data set that includes artists like Monet, all of Van Gogh's work, things like that. That's what we used for like selecting the target style. And then the stable diffusion model that we're training to be able to develop cloaks that counteract other models, I believe is trained on the Lion data set. But you're going to have to just look at the paper, and like it may be a frozen version of it from a specific time.
Okay.
So yeah, there's really no way to counteract these models without at least using some of the data that they're trained on. Otherwise, you can't build a feature space that mimics their behavior.
Makes sense. And then, yeah, kind of like bringing back the Nightshade thing, like, I guess, just curious how related exactly Glaze and Nightshade are, because, yeah.
They're somewhat related. To be fair, I was not at all involved in the development of Nightshade, other than suggesting to my co-authors that it become its own separate paper because it was originally going to be packaged in with Glaze. Nightshade is designed to be a broader poisoning mechanism. So Glaze is meant to prevent style mimicry of a specific artist, and Nightshade's vision is to kind of be toxic to diffusion models in general. So they're just different kind of threat scenarios.
Gotcha. Okay. Yeah, thank you so much. Appreciate it.
Thank you.
Okay, there doesn't seem like any more questions. And if you have more questions, you can always I guess take the questions offline with Emily. And thank you, Emily, for an amazing talk. We hope to connect soon again.
Yes.
Thank you.
Thank you very much.
Thank you.